Okay, section 8.1 is Intro to Parabolas. So we're going to graph a new shape. It's called a parabola. A function with degree 2 is called a quadratic function. So degree, remember, has to do with the exponents. So if the term with the highest exponent has an exponent of 2, we consider it a quadratic function. A quadratic function makes a U-shaped graph, which we call a parabola. So for example 1, we're going to complete the table and draw a parabola, so we have an idea of what that will look like in the future. Okay, so for the first example, A, it says y equals x to the second. I gave you some x values, and I'm going to go ahead and plug them in. Okay, so let's see, y equals x to the second. The first x value I gave you was a 2, so I'm going to plug in 2 to the second power. 2 to the second is 2 times 2, which is 4. Okay, next I'll plug in 1. 1 to the second power is 1 times 1, which is 1. 0 to the second power is 0 times 0, which is 0. Negative 1 to the second power is negative 1 times negative 1, and negative times a negative turns into a positive, so 1 times 1, 1. And then negative 2 to the second power is negative 2 times negative 2, which is positive 4. Okay, I'm going to go ahead and graph these points so we can have an idea of what this graph will look like. Okay, so my first point is 2, 4. The x is 2, the y is 4. So from the origin, I'm going to go to the side 2 and up 4. 1, 2, 3, 4, and put a point. Next, I have 1, 1. So I'm going to go to this from the origin, side 1, up 1. Then 0, 0, which is at the origin. My next point is negative 1, 1. So I'm going to go to the left 1 and then up positive 1 in the y direction. And then my last point is negative 2, positive 4. So x is negative 2, y is positive 4. And if I look at that, that's the shape of the parabola. It looks kind of like a U. This one happens to be opening upwards. Okay, and that's what we're going to be graphing this chapter. Okay, let's do one more. This is going to be y equals 3 times x squared. It will still make a parabola because it's degree 2, but it will look slightly different. Okay, so the equation is 3 times x, the first x is 2, squared. Because of order of operations, I have to do the exponent first. The exponent applies only to the base 2, so 2 to the second power is 4. So 3 times 4 is 12. Next, 3 times, plug in 1 for the x value. 1 to the second power is 1, so 3 times 1 is 3. 3 times 0 to the second power, 0 to the second power is 0. 3 times 0 is 0. 3 times negative 1 to the second power. Negative 1 to the second power is positive 1 because a negative times a negative is a positive. 3 times 1 is 3. 3 times negative 2 squared. Negative 2 squared is positive 4 because a negative times a negative is a positive. When I times it by 3, I get 12. Okay, I'm going to go ahead and graph this. The numbers are a little higher, but it should still make a parabola. So my first order pair is 2, 12. So I'm going to go in the x direction 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and in the y direction, I'm going way up to here. Okay, let's try 1, 3. So to the side 1, up 3. I still have a 0, 0 here. Negative 1, 3 means I go to the left 1 and then up 3. And then negative 2 up 12 is going to be up here. And I'm going to draw my parabola. This parabola happens to look a little taller. It has what we call a vertical stretch, which we'll learn about later. Okay, but it still makes a U shape. It also opens in the upwards direction. A couple things to notice about a parabola. The first thing is in the middle, there's this point. We call this a vertex. This one has 1, 2. And if you look on the left and right side, they are symmetric and they have matching points. So these 2 points are symmetric. These 2 match. Left and right match. Left and right match. And there's always going to be a matching point, which will help us graph it in the future. Okay, so let's look at quadratic functions a little bit. Okay, the first thing is this is what we consider standard form. It goes from highest degree to lowest degree, and it equals to y. The first word is vertex. It's the lowest or the highest point on a parabola. So I'm going to sketch a parabola over here. Okay, the ones we sketched over there opened in the upwards direction and look like this, but they could also open in a downwards direction and look like this. Okay, the vertex on the first graph is right here in the middle in this case, the vertex is at the very bottom of the graph, and we call it a minimum because it is the lowest point on the graph. Okay, on my other parabola, the vertex is going to be up here. Looks like it's in the middle. Because it's at the very top of the graph, it's the highest point on the graph, and we call it a maximum. Okay, the next word or vocabulary feature of a parabola is the line of symmetry. It's also called the axis of symmetry. It's the line that vertical line that divides the parabola into two symmetric parts. The line of symmetry is not part of the graph, it just helps us determine if our graph looks symmetric or find missing points. So I'm going to make it dashed because it's not actually part of the graph. Okay, if I draw a vertical line that splits the graph in half, right there, it always goes through the vertex. And then the left side and the right side of the graph on either side of the line of symmetry should look symmetric or like mirror reflections of each other. Okay, so for this graph as well, this would be the line of symmetry. If I had drawn that perfectly, the left and right side should look like they're reflections of each other. Okay, so on the next two graphs, I'm going to identify some of these features we just talked about, well, I'm going to find the vertex. I'm going to indicate whether it's a maximum or minimum, and I'm going to write the equation for the axis of symmetry. I'm also going to draw these points in. Okay, so if I look at the first one, the vertex is the point that's right in the middle, or the lowest and highest point. So in this case, it's this dot right here. That's the vertex. When we name the vertex, we give the ordered pair. So for this point right here, the x-coordinate is -2. The y-coordinate is -5, so the vertex is -2, -5. And you could also match it up saying this is the x, this is the y. It's always an ordered pair. Now, is it a maximum or a minimum? I need to look at the vertex and think, is it the lowest point or the highest point on the graph? This is at the bottom, so it's the lowest point on the graph. Because it's the lowest point on the graph, it is a minimum. The axis of symmetry divides the graph into two equal halves. I'm going to sketch it in. Then I'm going to write the equation. Okay, because it's a line, it has to have an equation, which means it must have an equal sign. Okay, because it's a vertical line, it always starts with x equals. If I want to see what x equals 2, I can see what the graph, where the graph hits the x-axis, it hits it at -2. Okay, so I can just look and see where it intersects the x-axis. If I didn't have the graph, I could also look at the vertex. On the vertex, the x-coordinate is -2, and that's another way I could determine the line of symmetry or the axis of symmetry. Okay, I'm going to identify the features on the next graph as well. Okay, this one is opening in the downward direction. The vertex is this point right here. I label it as an ordered pair. So in this case, the x-coordinate is 3. The y-coordinate is 5, and the vertex is always an ordered pair because it's a point. Is it a maximum or a minimum? Look and see if this is the highest or the lowest point on the graph. Because it is the highest point on this graph, it is a maximum. Okay, I'm going to sketch the axis of symmetry, and then I'm going to write the equation. Okay, axis of symmetry must be an equation. It always starts with x equals because it's a vertical line. I can get what x equals to by looking at the graph. It intersects the x-axis at 3, or I can look at the x-coordinate of the vertex, which is also 3. So my axis of symmetry is x equals 3, and don't forget it always must be an equation. Okay, the last thing we're going to do is sketch the graph of a parabola using the indicated information and what we know about the vocabulary. Okay, so I'm going to graph the parabola. I'm going to include the axis of symmetry and any symmetric points. I will show you what symmetric points means, but these are sketches, so I don't have graph paper, and it's okay if you don't either because we're going to label the points. Okay, I'm going to start off with the vertex. It tells me the vertex is 2, -3. I don't have a real graph, so I'm going to estimate about where 2, -3 is. X is +2, so it's somewhere over here. Y is -3, somewhere down here, and I'm just guessing. I'm going to put my vertex there. I'm going to label it because it's a sketch. The only way I can know what point it is because I labeled it. Okay, after I do the vertex, I'm going to draw the axis of symmetry even though I don't have a parabola at all. The axis of symmetry always runs through the vertex and it's vertical. So I'm going to go ahead and draw this axis of symmetry because it tells me where the kind of middle of my parabola is going to be. Okay, now the last piece of information they give me is the y-intercept is 0, 1. Okay, so on the y-axis, I'm going to plot the point 0, 1. 0, 1, and it is on the y-axis. I'm just estimating about where it is. Because it's not a accurate graph, I need to label the point. Okay, I'm almost done, but the last thing it's asking me to do is find any symmetric points. Okay, like we noticed on the previous graphs, there are matching points on the left and right side of the axis of symmetry. So if I look at this y-intercept over here, it's on the left side of the axis of symmetry. There has to be a matching point on the right side of the axis of symmetry for this to be a parabola. So first I'm just going to estimate about where it goes. It's probably over here somewhere. Okay, but then I'm going to label the ordered pair. Now for the y-coordinate, if this is 0, 1, this also has to be something, 1, because it's at the same y value or the same height. Now for the x-coordinate, it can't be 0 because this is 0. And I know that this is 2 because that's the x-coordinate of the vertex. So if I go from here to here in the x direction, I go 2 spaces. If I go 2 more spaces, now I'm at x equals 4. So this becomes 4, 1. Okay, and then after all of that, I have all 3 points I'm looking for. I'm going to sketch a graph from my parabola. It should look like a U shape. And I do put arrows at the ends. That's my sketch. Okay, we're going to do one more like that. It's just going to be a sketch. So it's okay if you don't have graph paper, just like me. I'm given the vertex and the y-intercept. Let's see, that 3, 9 is kind of tall, so I'm going to leave some tall space. Okay, the vertex is 3, 9. Okay, let me estimate. X is 3 is somewhere here. 3, 9, up high. I don't know exactly where, but I'm going to label it because I'm just estimating. Okay, after I do the vertex, I'm going to draw the axis of symmetry now. If you save it for later, you're likely to forget which point is the vertex. Okay, now let me graph the y-intercept. 0, 4. So along the y-axis, 0, up 4, 1, 2, 3, 4. It's an estimate. I'm going to label it because I don't know exactly where it is. Okay, now the symmetric point is going to be the one that's across this line of symmetry from the y-intercept. One on the left, one on the right. Okay, first I'm just going to guess where it goes because it's a sketch. That looks kind of even. Okay, the y value should be the same as the y-intercept because I went up 4. This also should be going up 4. Now for the x-coordinate, let's see, I start at 0. This is x equals 0. When I get to here, I get to x equals 3. So from here to here in the x direction, I go 3 spaces. If I go 3 more spaces, now I'm at 6. So the symmetric point should be 6, 4. Okay, and then I'm going to go ahead and sketch my parabola in. This parabola happens to be pointing down, but I'm still going to make it U-shaped, and I'm still going to put arrows at the end.